All right, welcome to lesson 31. This is going to be part one of two videos on this lesson. Lesson 31 is on square roots and rationalizing denominators. So we'll start with the first definition up here. It says, if b squared equals a, then b is the square root of a. So just a quick example for what we're talking about here. Let's see. I'll use the example of 3 squared. So if 3 squared equals 9, which is true, because by the way, 3 times 3 is 9, then what we say is 3 is the square root of 9. But the thing is, there's actually more than one square root of 9. So when we say 3 is the square root of 9, really what we mean is that it's the principal square root of 9. So if we keep reading, it says, if a is positive, it has 2 square roots, one positive, one negative. So actually, 9 has 2 square roots. 3 is one of them, and -3 is another square root. The reason for that is if you square 3, you get 9, as you know, but also if you square -3, that also gives you 9, right? So there's two different possibilities that you can square to get 9. So those are the 2 square roots of 9. 3, that's the positive one, that's called the principal root. And then -3, that's just called the negative root. Usually what we're talking about is the principal root. Okay, so the positive root is called the principal root, as we said. And that's when we get to use this square root symbol. So b equals the square root of a. This is the symbol for principal root. So if I put that symbol over the 9, that's probably what you're used to seeing with the square root of 9. It kind of looks like a long division symbol, but with kind of more of like a V shape on the left side, the square root of 9. We would just say it's 3, but the thing is that symbol indicates just the positive answer. Okay, so b equals the square root of a. This means that b is the principal root of a. Normally we just call it the square root. Okay, and then the next thing we're reading here, it says if a is negative, then there is no real root. So what that means is if we try to take the square root of a negative number, there's no real answer to that. The answer would actually be something called an imaginary number, believe it or not. Some of you may have heard of that before, depending on your experience with high school math and algebra and pre-calculus. So if you've heard of imaginary numbers, great. If not, don't worry about it. We're not going to cover those in this course. So what you need to know is when you try to take the square root of a negative number, for example, the square root of -25, we would just say there's no real root. It's not 5, and it's also not -5. Okay, why is it not -5? Well, just a little example here. The square root of -25, first of all, if you put that in your calculator, you're going to get something like domain error, which is sort of a clue that there's no solution, no real root. But if you're wondering why it's not -5, think about it. If you take -5 and you square it, -5 times -5 is actually +25, right? It's still not going to give you that -25. So there's no real number that you can square to get to a negative answer. So in summary, if you have a negative number underneath that square root, there is no real root of that number. So again, the square root of -25, we'd say there's no real root. It's not 5, and it's also not -5. Okay, so here's our first real examples down below. Number 1 says, find the square roots of 16. Okay, there's an S at the end of that word roots, right? So there's going to be 2 answers. The principal square root of 16 is 4. Okay, remember principal, that's the positive root. The negative square root is -4. Okay, and the reason why these are the answers, that's because 4 squared is 16, and -4 squared is also 16. So again, 4 would be the principal square root, -4 would be the negative square root. And these are kind of fill in the blank sentences. We're not using that actual square root symbol yet. Once we bring that symbol in, we have to just give the positive answer only. Okay, the next examples involve fractions and decimals. Don't be too scared, we can use a calculator for this. So the next one is evaluate the square root of 0.36. Now, in just a minute, I'm going to show you how to do this on a calculator. Maybe I'll show you right now. Let's see. I'm going to change our screen here for a moment. And we're going to go, we're going to go find a picture of a calculator to look at. Let's see. There it is. Okay, so the calculator that I'm showing up here is a scientific calculator. It's a TI-30X2S. So this is a pretty common calculator model. If you have a different one, that's fine. If you're not sure how to do square roots on your calculator, probably you can look it up. If you Google the, the model of your calculator, you can probably figure it out, or feel free to ask and I'll be happy to show you in one of our Zoom times. But I bet you can figure it out. Okay, so for this calculator, to take the square root, I'm finding the x squared button. So on this particular calculator, it's on the left side, kind of right next to the number 7. So let's see, 1, 2, 3, 4. It's about 4 buttons up from the bottom, all the way on the left side. So the button, if you can't read it on the screen, it has x squared on the button. Right above it is a square root symbol. So because it's right above it, kind of in that blue color for this calculator, that means I'm going to need to use the second button. Some of you might have a shift key or something. So for the problem that we want to figure out, the square root of 0.36, what I'm going to do is second, and then the x squared key, and then I'll just type in the number, right, 0.36, and then enter or equals, and then that will give me my answer. Okay, this is not an actual calculator that we're looking at, it's kind of just a screenshot. So I'm going to do it on my own calculator and then I'll tell you what I see here. All right, so here we go, 0.36, okay. So the answer that I'm getting is 0.6. So with whatever calculator you have, make sure you're getting the same answer, okay? So again, the square root of 0.36 is equal to 0.6. So we just use our calculators for that. You can check it by doing 0.6 squared, 0.6 times 0.6, and you should get back to 0.36 as a way to check. Okay, good. So I'm going to go back to our PowerPoint now so we can fill that in. So we just evaluated the square root of 0.36 and we got 0.6. And again, this is the principal root now. Here's number 3, find negative square root, and then under the square root is 49 over 25. So what we're going to do is actually split that apart. First of all, I guess I should back up and just acknowledge there is a negative sign, but it's outside of the radical. It's coming before the square root. And if I haven't said this already, when I say radical, that's sort of a more general term for root. So we're focusing on square roots. There are also cube roots, fourth roots, and a lot of kinds of roots, and they're all called radicals. So if I say radical, I just mean root. It's the same thing, really. Okay, so outside of the radical sign or square root sign, there is this negative. That's okay because it's outside. It's kind of like it's a -1 multiplying by the answer. So let's focus on what's under the square root. There's a fraction, 49 over 25. Think of it like you're doing the square root of 49 over the square root of 25. We can kind of split it apart like that. These are both numbers we should recognize. So the square root of 49, that would be 7. And the square root of 25, that's 5. So that's it. My answer is -7 over 5. And again, we did have an answer for this because the negative was on the outside of the square root. If the negative had been inside the square root, that's when we would say there's no solution or there's no real root. Okay, so we're done with our first slide. Let's keep going. Okay, we're going to do a little bit more with our calculators, and then we'll be solving some kind of without a calculator and using factoring, believe it or not. Okay, so the next 3 problems, the directions are approximate the square root using a calculator, round to the nearest thousandth. So we've already talked about how to use a calculator to do these. Okay, so depending on your calculator model, you might be hitting the shift key or the second button, and then x squared, whatever you need to do to access that square root symbol on your calculator. So here's number 1. It's the square root of 484. Okay, so I'm going to use my calculator. Whoops, go back. Sorry about that. Okay, so I'm using my calculator. I'm going to use this kind of squiggly equal sign right now because I know I'm going to be rounding. So the squiggly equal sign just means approximately. Okay, so in my calculator, I'm gonna do the square root of 484. Oh, and this one, actually, I don't need to round. It just comes out to a nice whole number. So the answer is exactly 22. No rounding necessary for that one. Okay, the next one I think will require some rounding. Let's find out. So number 2, the square root of 180. Okay, yes, this one is taking up my entire calculator screen. So we will need to round. Here are some digits that I see. So I'm seeing 13.416407886. Okay, and then you're probably running out of room close to after that. I don't need any more. I really just need to round to the nearest thousandth. So the thousandths place would be 3 places to the right of the decimal. So let's go back and find where that is. So again, we had the square root of 180 is approximately 13.416. Okay, so the 6 is in the thousandths place. So remember, for rounding, look at the number that comes after the place you're rounding to. So if 6 is in the thousandths place, look at the number that comes after it, which happens to be a 4. If the number is below 5, you keep it the same. If the number is 5 or higher, we round up. So because the 6 is followed by a 4, we do not round up, we keep it the same. So our final answer will be 13.416. So that is the rounded answer. So be careful when you're entering your answers on MyLabs Plus. It does matter that you're rounding correctly. Don't round too much, don't round too little. Okay, so there's one more to do. So this is number 3, the square root of, this is a fraction now, 185 over 46. Okay, so depending on our calculator models, we might have just a little issue with this. So I am going to take us back to that screen where we had the image of the calculator. So it's 185 over 46. Okay. All right, so I'm just going to write that down before I forget it. All right, square root of 185 over 46. Okay, so let's figure out how to enter that on our calculator. All right, so what I can do is I can still start by hitting the second key. So second, and then x squared. Okay, and then that will kind of show that square root symbol up at the top screen. Then to enter a fraction, there's this ABC key that I have here. It's barely readable on the screen, but it says ABC. It kind of looks like A and then B over C, like it's a mixed number. I'm guessing most of you are used to using that already to do some fraction calculations, but we're going to use that to enter our fraction. So 185, and then I think you hit the ABC key after that, and then the 46. Okay, so I might have gotten that out of order. Let's back up. So second, then x squared. So then you should see a square root image up at this on the top of your calculator screen if you're doing this. Then I'm typing 185, that's the numerator of my fraction. Then the ABC key, then you'll see a kind of this little, I don't even know what to call it. It looks like a backwards L, it's like a little corner image. And then 46, and then enter. Okay, once you do it on your own calculator, I'm sure you'll be fine. You probably don't need me to try to show you on this weird screenshot here, but we don't want you to get calculator questions wrong, okay? Those should be the ones you get. So if you're having trouble and your answers aren't making sense or aren't working, please reach out and we'll try to solve the problem together. Okay, so let me actually do this now on my real calculator that you can't see. So I'm gonna write this down. Okay, so the answer I'm getting is 2.0054274, and some more numbers after that. Once again, we're going to round to the nearest thousandth. So 2.005, so 5 is in the thousandths place. It's followed by a 4, so just like last time, we're not going to round up. We'll keep the answer exactly the same. So it will be 2.005 for our rounded answer. Okay, so let's go back and fill that in. Okay, so now we're back to our PowerPoint here. We used our calculator. We got approximately The square root of 185 over 46 was approximately 2.005, rounded to the nearest thousandth. All right, good, let's keep going. Okay, now we're gonna start talking about simplifying without a calculator. Okay, so the title of this slide is Some Useful Properties of Radicals. Okay, so we're gonna be talking about multiplying as well as factoring or dividing. Those are kind of all connected. So the first thing you're seeing here is the product rule for radicals. So again, there's that word radicals. This is kind of a generic rule that applies to any kind of root, square root, cube root, fourth root, any root. We're focusing on square roots in this class. Okay, so the nth root of A times the nth root of B is equal to the nth root of A times B. Again, n can be anything. In this case, we're just focusing on square roots. So the square root of a number times the square root of another number, what you do is you join them together into one square root and you multiply them. Okay, so for example, the square root of 2 times the square root of 3, that would be the square root of 6. I'll just write that out. So example, square root of 2 times square root of 3 is equal to the square root of 2 times 3, which is the square root of 6. So that's just a quick example using the product rule. Okay, now the quotient rule is similar. The square root of A over the square root of B, that can be written as the square root of A over B. So these are examples where we can take two square roots and join them together using multiplication. We can also split them apart using multiplication. We can join square roots together using division. We can also split them apart using division. Okay, so let's take a look at some examples below. I guess before we do that, this quotient rule, we kind of already used it today. So I'll just quickly show you that. So we actually used it in reverse. Remember, we had this problem where it was the square root of, I think it was 49 over 25. Remember how we split it apart into square root of 49 over the square root of 25? That was using the quotient rule. We already did that. And that's how we were able to get that 7 over 5. Okay, so these rules are very useful. We can kind of pull square roots apart and put them back together. Okay, so I think that's what is kind of being said in these next couple of sentences. We can use the product rule in reverse to split up a square root. That's going to be factoring, basically. Okay, and then here's kind of the next step. We're going to find a perfect square factor to simplify and pull out of the radical. Okay, so here's where we're going with this. We're now going to see square roots that don't necessarily have a nice whole number answer. So here's our examples on this page. The square root of 484. Now we already saw this number. We used our calculators earlier and we got the answer of 22, but here's how you could do it by factoring or by breaking the number down. So the square root of 484, we can break it down using perfect squares. So now might be a good time to kind of have a list nearby of some perfect squares. So here's what I mean by that. The square root of 1 equals 1. The square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. We'll keep going. Square root of 25 equals 5. Square root of 36 equals 6. Square root of 49 equals 7. Let's see. Square root of 64 equals 8. I'm almost out of space. Square root of 81 equals 9. All right, I was hoping to get us up to 12. Let's keep going. Let's see. Square root of 100, that's 10. Square root of 121, that's 11. Square root of 144, that's 12. Okay, there's more. Literally goes on to infinity forever, but that's a good list to be familiar with. Okay, so back to our example, the square root of 484. If we look at this list, we can find factors that go into 484 that are perfect squares. So the ones that we're going to focus on, we'll start with 4. Okay, so if I kind of break this down, 484 divided by 4 is 121. And I'm writing it kind of as a factor tree, but you can also write it more horizontally. The square root of 44 can be broken down into the square root of 4 times the square root of 121. The square root of 4 is 2, and the square root of 121 is 11. So basically we just have 2 times 11 And that's one way to get our answer of 22. And that's theoretically possible without a calculator. Okay, so you can kind of make a factor tree in a way, but you really want to only focus on perfect squares when you're breaking these numbers down. Here's another example, a smaller number, the square root of 63. Now this one, if you go to your calculator to do it, you're going to get a never-ending decimal. And unless the directions are asking you to round, pretty much from now on, we don't want decimal answers. Okay, so we're only going to focus on perfect squares. So if I look at the square root of 63, let's focus on the number 63. What perfect squares do we know that go into 63? If I look at my list, I mean square root of 1, but that's not really helpful. So I'm going to kind of breeze past that. The square root of 4, unfortunately, does not go into 63, but how about 9, right? 9 does go into 63. So I can break this down into the square root of 9 times the square root of 7. Okay, 9 is a perfect square. That's why I'm doing it this way. So I'm factoring the number 63 using at least one perfect square. In this case, it was 9. So again, the square root of 63 breaks down into the square root of 9 times the square root of 7. The square root of 9 is 3, so that pretty much gets pulled out of the radical. It gets pulled out of the square root. And then the 7, we can't simplify the square root of 7, so that stays where it is. So my final answer, when I simplify this, the square root of 63, again, we broke it down into the square root of 9 times the square root of 7. And our final answer is 3 square root of 7. Or 3 times square root of 7 is another way to say that. Sometimes we even say 3 root 7. So depending on how advanced your calculator is, most calculators cannot do this process. The TI calculator I was showing you earlier cannot do this. I'm sure some of you have more advanced calculators that can, but this is the work you're expected to show. So this is a type of problem where you really shouldn't be skipping straight to the final answer. Show the factoring steps. Show that you understand that there's a perfect square factor of 9 that goes into 63. You want to show that square root of 9 times square root of 7, and then the answer 3 square root of 7. Okay, so we're going to do a few more like that. We have 4 examples on the next slide, and our directions say simplify by factoring. Find perfect square factors to simplify. Okay, so we made a list on the previous slide. I'm pretty much going to reference that list again as I'm trying to break these numbers down. So usually, not always, usually it comes down to using the square root of 4 or the square root of 9. Not always, but a lot of times it's those. Okay, so 4, here I'll just make a short list over here. Square root of 4 is 2, square root of 9 is 3, do a couple more, square root of 16 is 4, square root of 25 is 5. I mean, a lot of times it's those. So I think just those 4 square roots are going to get us through these problems. Okay, here's number 1, the square root of 12. Okay, so if I think about a perfect square that goes into 12, look at our short list over here. 4 goes into 12, so let's just use that. So here we are, we're going to break down the square root of 12 using the square root of 4 times the square root of 3. Again, we're doing this because the square root of 4 is a perfect square that we will be able to simplify. Okay, 4 times 3 is 12, so we're able to split this apart, really using that product rule kind of in reverse. Okay, so the square root of 12 is equal to the square root of 4 times the square root of 3, and we simplify that by writing 2 square root of 3. And that's it. Okay, so the square root of 12, not a whole number. And by the way, it's not 6. Sometimes students think you just cut the number in half, but that's not going to work. 6 times 6 is not 12, okay? So this would be a long decimal. We're not interested in decimals right now. We're getting exact answers using radicals, okay, using that square root symbol. Okay, so again, square root of 12, broke it down into square root of 4 times square root of 3. And the answer we got is 2 square root of 3. Let's do number 2, which is similar. It's going to be the square root of 20. That is also a multiple of 4. So let's break it down again using the square root of 4. 4 times 5 is 20. So I'm going to break this down using the square root of 4 times the square root of 5. And that becomes 2 square root of 5. So here's our final answer, 2 square root of 5. All right, number 3. This is the square root of 45. Okay, so we can't use 4 for that one. Let's look at our list. Looks like 9 is a good option. So the square root of 9, that's going to be a good factor we can use to break down 45. So 45 is equal to 9 times 5. So we can write this as the square root of 9 times the square root of 5. The square root of 9 is 3, so we can just write 3 square root of 5. Okay, so again, square root of 45, break it down. Square root of 9 times square root of 5, and that's now just 3 square root of 5. Okay, there's one more on this slide here. So the square root of 50 is our next one. Okay, so going through my list, 4 doesn't go into 50. 9 doesn't go into 50. 16 also doesn't go into 50, okay, but 25 does. Okay, so the square root of 50, let's break it down, this time using 25. So 25 times 2 is 50. So we can split this apart. Square root of 25 times square root of 2. The square root of 25, now that gets simplified to 5. And then this time the square root of 2 just stays where it is. Okay, we can't simplify that anymore. Okay, so as we're looking at the answers here, it looks like we have a bunch of 2s, 3s, and 5s. Those are pretty common answers. All right, so pay attention to how we used perfect squares and we simplified perfect squares. Whatever simplified, that was the number that came to the outside of the problem. Whatever number couldn't be simplified stayed inside the problem, inside the square root. So for example, in square root of 50, we broke it down using square root of 25 times square root of 2. The square root of 25 simplifies to 5. The square root of 2 is nowhere to be found in our list up here, okay? The square root of 2 is not a nice number, so we can't do anything to it, so we leave it in the final answer. The final answer is 5 square root of 2. Okay, so that's as far as we're going to go in the notes in this video. The next video will pick up with the next set of problems on multiplication. So the remainder of this video, we're going to look at some examples in MyLabs Plus, and we'll just make sure we understand how to type in the answers using that square root symbol. Okay, so I'm going to pause and then take us to MyLabs Plus. Okay, so here we are looking at homework 31, simplify square roots and rationalize denominators. So this first part of the video, we just pretty much focused on simplifying square roots. You'll see in part 2 more about multiplying, dividing, and rationalizing denominators. So we'll just focus on some problems from basically the first half of this assignment, from problems 1 through 14. So here's number 1. It says find the square roots of 36. And it's going to ask us in 2 parts. So it says the principal square root of 36 is, so that's where I'm going to write positive 6, because 6 squared is 36. And then the second part, now it's asking me for the negative square root of 36. So the negative square root of 36, that would be negative 6. Okay. Let's see, that was number 1. Number 2 is similar. I'm going to skip past it. It's a bigger number. You can use your calculator, the square roots of 196. So that's going to be positive 14 and then negative 14. I'm going to skip past that one. All right. Oh, number 3, similar. Square roots of 400. Let's see. Do I know that one? I think that's going to be positive 20 for the principal square root and then negative 20 for the negative square root. So far, so good. You can use your calculator if you need to for these. All right, now we see our first fraction question. This is number 4. Find negative square root 16 over 9. Okay, now remember, keep the negative on the outside if it's there. That's fine. That means our answer will be negative. If we split this apart into square root of 16 over square root of 9, then we can simplify. The square root of 16 is 4 over, and then the square root of 9 is 3. So our final answer here would be negative 4 over 3. All right, that was number 4. Number 5, all right, find the following, the square root of 625. Now I'm saying square root, but I'm not seeing those words. Now we're seeing that actual symbol, which means there's only going to be one answer. Okay, so just remember this symbol that maybe you've gotten used to seeing, it really is a symbol for principal root, so only the positive answer. Okay, so I'm just kind of jotting that down. All right, so the square root of 625, let's try it on your calculator first. If we get a whole number, then that's great. If not, then we'll have to do that factoring process. Okay, yeah, so this one does simplify nicely on the calculator. The square root of 625 is just 25. Okay, so if you try something on the calculator and you get a long decimal, check to see if the question is asking you to round. If not, that's when you know you're going to be needing to factor. But we're not there yet. Okay, so that was number 5. Now we're at number 6. Okay, this is a decimal question. Simplify 0.0036. So I'm going to just use my calculator for that, and I'm getting 0.06. Okay, so there's not really much interesting stuff to show you with this for these calculator questions. I'm just saying use your calculator. So that's good practice for you to use that tool and just make sure you're getting the same answers as you're following along. Okay, next one, this is number 7. Find the square root that is a real number. So this one is the square root of, and then under the square root is -4. Okay, so if I type this into my calculator, let's see what happens. All right, and I'm using a different calculator today, so I'm a little lost. Oh, I did it, okay. So I'm just using my iPhone right now. It just says error, but on my actual TI calculator, that would say domain error. This is not a real number, okay? So there's actually 2 choices for this one. So we have to choose choice B. The square root is not a real number. Let's just see what happens if I type in the wrong answer here. So I'm just gonna type in -2. That is not the right answer, but I'm gonna see what it says. Okay, it says, remember that the square root of a negative number is not a real number. Okay, so there you go. And again, the reason why it wasn't -2 is because -2 times -2 isn't -4. -2 times -2, that would be +4. So one of the rules we learned is whenever you have a negative number under the square root, that is not a real root. That square root is not a real number. Okay, so that was number 7. All right, now we're getting to some approximate questions. So number 8 says approximate the square root. The square root of 180. I think we did this one in the notes, round to the nearest thousandth. I'm going to skip over that one. Number 9 is a fraction. Use a calculator to approximate the square root. The square root of 125 over 46, round to the nearest thousandth. Again, we did similar ones like this in the notes, so just remember how to punch it into your calculator and remember to round correctly. I'm going to keep going. I want to get to the factoring questions. Okay, here we go. So number 10, the square root of 63, and the directions say simplify by factoring. Also notice under the answer box, it says type an exact answer using radicals as needed. So that word exact, that means we are not rounding. So if you've kind of gotten comfortable using your calculator and then you put this one into your calculator and get a long decimal, that is not what's being asked here. So simplify by factoring, that means this is where we're going to start breaking the number down. So actually, I think we saw this one already today. The square root of 63, that was 9 times 7, right? So the square root of 9 times the square root of 7, that turns into 3 square root of 7. So let's type that answer in, and then we'll learn how to type that square root symbol. Okay, so again, it's 3 square root of 7. So I'm going to type 3. And then kind of right in the middle of the toolbar here, let's see, 1, 2, 3, 4, the 5th button from the left is this square root button. So that's what I'm going to click on next. And it just puts a square root in there, and then I'll just type 7 underneath it. So the square root of 63 is 3 square root of 7. All right, in case you're wondering, the button after it, that's called the nth root. We don't really need that in this class, but you will for college algebra when you start learning about 3rd and 4th and 5th roots. All right, but for us, we're just using square roots. So that was number 10. Let's do another one, simplify by factoring. This is the square root of 90. Okay, so the first thing I'm thinking of here is 9 times 10. Is that helpful? Let's see. If I break down the number 90, yes, 9 is a perfect square. Okay, so the square root of 9 times the square root of 10, you can just write that as 3 square root of 10. Now, sometimes we need to be a little careful and see if we're breaking it down far enough. So here's a slightly longer way you can do this. I'm about to show you a slightly different method here that I didn't show in the notes. So I'm going to clear this. We'll get the same answer. Okay, so let's just take the number 90 and let's forget about square roots for a second. Let's just break it down. Okay, so any number will be fine. Maybe you would prefer to divide by 2 first, just because that's how you're used to doing factor trees. That's fine. So 90 divided by 2, that's 45. Let's break down 45. Let's see, 9 times 5. All right, and then 9 breaks down to 3 times 3. So I just made a classic factor tree here, okay? So again, I started with 90. You could break this down in any order if you do it this way. I'm going to circle my prime factors right now. The prime factors are the ones that can't be broken down anymore. So I have 2 times 3 times 3 times 5. So here's another way to simplify a square root. I can write the square root of 90 as the square root of 2 times 3 squared times 5. See what I did there? 3 times 3, I just wrote it as 3 squared. The square root of 3 squared is just 3. Okay, so let me rearrange this a little bit. The square root of 3 squared times the square root of 2 times 5. So I just broke down my radical and I rearranged it a little bit. So I pulled the square root of 3 squared kind of off to the left side, and then times the square root of, and then I left the 2 times 5. To finish simplifying this, the square root of 3 squared, that's just 3. And then underneath the square root, we had 2 times 5. We just put that back together and we get 10. So the reason why I didn't teach it like this at first is because this is much longer than the way I had showed you before with looking for perfect squares. But this is another way that you can simplify square roots. You can make a factor tree, and you're essentially looking for pairs of the same factor. So that pair of 3's really meant that we had a 3 on the outside of our square root in the end. So the square root of 90, I broke it down into the square root of 3 squared times the square root of 2 times 5. The square root of 3 squared became 3. And then 2 times 5, we put that back together and we got 10. So if you didn't like that or that was more confusing, then let it go. It's fine. Remember, just one more time, here's sort of the shortened version. Square root of 9 times square root of 10 is just 3 square root of 10. That's my preferred way, but I just wanted to show you an alternative way of getting it, because sometimes we can't think of the perfect square right away. Okay, good. So that's number 11, just a couple more here. Number 12, a little bit bigger. This is the square root of 175. Okay, so I just showed you how to do this using a factor tree. That would be fine if you wanted to do that. I would say if you see a number that ends in 5, see if it's a multiple of 25. So I'm going to use my calculator and try doing 175 divided by 25. Let's just see if that works. 175 divided by 25 is 7. Perfect. Okay, so I can split this up using the square root of 25 times the square root of 7. And that's now just 5 square root of 7. Okay, so that actually wasn't so bad. If you did make a factor tree, maybe you would just divide by 5. Let's see. So here's an alternative way over here. So 175 divided by 5, that's 35. Break that down into 5 times 7. So your factors end up being 5 times 5 times 7. So that's the square root of 5 squared times 7. The square root of 5 squared is just 5 on the outside, and then the square root of 7 stays on the inside. So there you go. You kind of have 2 different ways of showing the work, just whatever works for you in that particular problem. All right, so 5 square root 7. Okay. Oh, and Number 13 is literally the same number. That is weird that that just happened. Okay. Yep, it's a repeat of the same question. Well, great. Okay, so I'll just move on to 14. And here's a multiplying question. Are we ready for this one? Let's see. I thought that didn't come till 15. Okay, well, I'll end with number 14. This is kind of a preview of the part 2. It says multiply and then simplify by factoring if possible. Okay, so you saw the product rule already. We're going to use that right here. So it's the square root of 5 times the square root of 15. We get to multiply those together under one square root. So 5 times 15, that comes together under the square root. And once again, just making sure I said it already, the square root of 5 times the square root of 15 equals the square root of 5 times 15, and that is the square root of 75. So I do need to simplify by factoring if possible. So if I type my answer in right now as square root of 75, I'm not going to get it right. So it says the radicand can be factored using a perfect square factor. This word radicand, I don't think I taught you that yet. That's the word for the number under the radical. So in this case, the square root of 75, 75 is the radicand. So we can break it down more using a perfect square. Okay, so here's how we can do it. 75 can be factored using a perfect square of 25. So we can break it down into 25 times 3. So the square root of 75 can be written as the square root of 25 times the square root of 3, and that would just be 5 times square root of 3. Or maybe you can't think of that right away, okay? Maybe you don't know what goes into 75. That's okay, back up to the previous step. Remember how we got it in the first place? 5 times 15. So just go back to that, then break down the 15, that's 5 times 3, and there you go, you have your factors written out, 5 times 5 times 3. The 5 times 5, there's your 25, right? So the square root of 5 squared times the square root of 3 still gives you back to the same answer. So the square root of 5 squared, that would just be 5 on the outside, and then the square root of 3. Okay, so let's type that answer in, and I think we're gonna wrap it up and take a little break before we see part 2. Okay. 5 square root. Oh, and by the way, in case you notice, I'm not always clicking on this square root button. If you hover your mouse over it, it shows you a little keyboard shortcut. So it's this backslash and then SQRT. So that's what I've been typing, in case you were wondering. So I typed 5 and then backslash SQR. And then when I type T, it's magically going to turn into a square root. And then I typed the 3. So, all right. There we go. Okay, I'm going to stop here. So good job. Take a little break, come back and check out part 2, where we're going to see more on multiplying square roots as well as dividing, and you'll learn about what it means to rationalize the denominator. All right, see you soon.